All right, let's get started. First, good morning. Thanks for coming. This is Friday and the last day of the conference, and appreciate you come. And hopefully you'll find the time is worthwhile for you. The information is will be useful for you. So I'm Charlie Wen. I'm a PM, Program Manager from Windows networking team, core networking team. And this session is about Hyper-V network virtualization. So before I start, I just want to have a quick show of hands. How many of you have heard of Hyper-V network virtualization? Oh, good, very good. A lot of you. We usually just call it HMV. How many of you actually tried it, meaning like deployed even including a lab environment? Quite a few. How many of you actually tried deployed in a production environment? Wow, that's impressive. So we did a lot of work in 2002, and hopefully we actually move all the hurdles, and so we can encourage more customers to take a look at this new technology and deploy it in your environment. So we'll talk about Hyper-V. We'll give an overview because still relatively it's a pretty new concept. We introduced HMV in Server 2012, which was less than a year ago. We heard feedback from customers, from readers, and some concepts are not that clear. Our documentation doesn't make it clear. So hopefully, in this session, I'll make things a little bit easier for you to understand. And so I'll talk about concepts. I'll spend a large portion of this session really to focus on what's new, what we introduced in Windows Server 2012 R2, and make it easy for you to deploy. All right, so if you have been to the networking overview session, which is on Wednesday, you should be familiar with this slide. So basically, this summarizes our investment in R2. So basically, we have three areas. We focused on performance and the diagnosability in the platform. So make it easy to use the existing hardware and make it performant. And we invest in the diagnostics tools for you to troubleshoot networking problems. The second area is SDN. We take the first step at SDN by introducing this HMV in 2012. And with R2, we make it more comprehensive. And the last one, but not least, is we also invest in core infrastructure network service. That includes IPAM, DHCP. We have actually had a session for that too. If you miss it, please go back to channel 9 MSDN, and you can get that information. Okay, so what is Hyper-V network virtualization? So the question is why we invest it, right? So where the requirements come from? I think the short answer is the requirements actually come from our partners and customers. So at Microsoft, we actually have worked with Azure, Bing, and Office 365. Right? They actually operate some of the largest networks in the world. And we also work with a lot of partners and customers. So basically, they constantly give us a feedback and the requirements, and we summarize them into 4 buckets. The first area is when customers look at networking, they don't want to look at the networking as an isolated resource. Right? In a data center, you have a compute, you have storage, you have networking. They want to look at the network as a pooled resource and have an integration with storage and the compute. The perfect example I can give you is think about live migration. Right? I think everyone knows about live migration. Now, when you migrate a VM from one rack to another, for example, now if you're using today's technology, that means you have to make sure you configure not just on the server side, you have to do the live migration Hyper-V switch configuration. You also have to configure the Tor, the access switch, make sure when you live migrate the VM, you still have the connectivity. So that's actually created some dependency between compute and the network. that kind of a block automation. Automation is really very important when you operate, when you manage a larger scale data center. The second requirement is, regardless whether you are a service provider or you are private, you are enterprise, you have your own private cloud, you want to support multi-tenancy. Right? Your customers could be external customers or could be your your own business units in your company. So when you onboard these customers on your infrastructure, they demand to have some sort of isolation. Whether they use isolation for performance purpose or for security purpose or having other sorts of policy requirements, they demand to have this isolation. And that's why it's key, it's critical to create this multi-tenancy environment on your infrastructure. So that's the second requirement. The third requirement is we look from service providers such as Azure's point of view. Now, Azure's customer or other cloud service center, providers' customers are thinking about cloud computing, moving their workload to the cloud. They think about hybrid IT. They want to be able to move their workload to cloud seamlessly, easily. They don't want to have so many hurdles they have to jump over because that won't be worth their time. That won't be worth their resource to invest. We want to make sure it's easy for them to migrate. So that's the third requirement. Last but not least, almost everyone wants to reduce the cost. If you look at the data center today, the complexity, the scale, reduce the cost is really key for whether you're a service provider or you're enterprise to compete. So that's the requirements. So next thing I will talk about is SDN, Software-Defined Data Center. Actually, we have an entire session for it, which is at 12 o'clock. I encourage you to go to that session. So I'm only going to just touch base on this. So given the complexity and the scale of the data center, using traditional ways to configure the data center, network, compute, and storage is no longer feasible. Right? I talked about the live migration example. It's no longer feasible for you. Every time you have to live migrate a VM, you have to log out, you have to go to your physical infrastructure and configure this, configure that. It's no longer feasible. So we want to enable software to automate, to make that process easy. So one thing is, SDN is a buzzword, right? What is SDN? So the way we see it is actually, we see it fits in three areas. One is to abstract physical infrastructure, abstract physical network. I'll talk more about it. And second is now you have this your virtual network, a virtual environment, and your physical environment. How can you use a policy? How can you use a policy software to manage both? So you don't have to treat these separately. And the third, you actually control traffic, right? How you actually direct to the traffic engineering, avoid some congestion in the network, and that's third. Now, Hyper-V, HMV is really technology that abstract the physical network from the virtual networks. So this is the session we'll focus on. And in the SDN session, we also talk about the other two. Okay, so I talked about abstracting the physical network. I think the best way to explain this is actually take a step back and look at the server virtualization, because that's actually a concept I think many of us are already familiar with. So when you look at the server virtualization, essentially you have a pool of physical servers, right? And then we create an abstraction layer, which is Hyper-V, and then on top of this abstraction layer, you can onboard virtual machines, right? Now, from the user of these virtual machines point of view, they are just working on physical machines. Really, there's no difference from them. They just run their application, they run their service in these virtual machines. Hyper-V provides this isolation. Network virtualization has the same idea. So instead of a pool of physical servers, you actually have a physical network. Right? How we actually can create an abstraction layer so that tenants can onboard their network, virtual network. So from each tenant's point of view, they have this, each tenant owns this network, virtual network. They can bring their own IP address, bring their own topology, and we'll spend more time on that. So this is really network virtualization. Now, server virtualization, we implement Hyper-V to provide this abstraction layer. How do we implement, how does the network virtualization work? How do we implement network virtualization? We used something called overlay technology. Basically, we build an overlay on top of the physical network, and we use a pretty traditional, typical method called packet encapsulation. So I think some of you heard about NVGRE, and we use a packet encapsulation to create this, to separate the physical network address space and the logical, the virtual network address space. And I will talk more about that in details. Okay, so I'll talk about briefly the benefits. So we talk about the, why we investigated, or why we invested. Let's talk about the benefits. There are really we think there are four stakeholders, parties can benefit from this one. The first one is actually workload owner. That if you are application owner, if you are service owner, think about like in the past, when you, let's say you expand your service, right? You need more resource, for example. What do? Right? You probably will need to, because you need more VMs, you need more servers, you will probably, but that means you need more infrastructure support, network support. So you open a ticket, so your networking team, infrastructure team will handle the ticket. That process can take, an order of hours if it's quick. If it's slow, it will take days. With HMV, we can make this kind of a process seamless and quick. And also in the past, when you try to expand your capacity to meet your requirement, and the network infrastructure team will say, oh, you have to make some changes so to accommodate the physical topology. With network virtualization, our message is, no, you no longer have that dependency on the infrastructure. So that's from the application and service owner's point of view. Now, for enterprise, you manage this private cloud. We talk about the server virtualization. For this enterprise, they want to be able to consolidate the resource, the network resource, just like they consolidated the computer resource. And they're also thinking about, if the enterprise is thinking about moving their workload to the public cloud, they're also thinking about the hybrid hybrid networking. So this is actually HMV will make this possible, because you can move your infrastructure, your IP address seamlessly to the public cloud. From hosters, the third party is from hosters. So should be pretty straightforward, because if you are a service provider, you want to enable scenarios such that your tenants, your customers can bring their own IP and topology, and you want to support multi-tenancy. And the last, admin. Right? If you are admin, this is really the flip side of the application and the service admins. This is really the flip side of application and the service admin. Because in the past, you have to answer their request. Right? You have to do a lot of configuration, provisioning, and testing before you can tell the application service admin, and okay, it's ready, you can deploy. But with Hyper-V network virtualization, you can do things in your layer, in your provider's address, on your infrastructure, without affecting the application and the service admin. Okay, so this is really the very high level what HMV is about. So the next thing I will talk about is concepts. As I mentioned, it's still pretty new technology. And it's not simple. Sometimes it's complex, and we try to. So I try to make sure some of the concepts get crossed, so you understand we what do we talk about when we use different terminology. So the first thing is virtual network. So I mentioned about virtual network, physical network and the virtual network. When you use SCVMM, so our recommended way to manage HMV is SCVMM. So when you use SCVMM to manage HMV, you actually bump into this terminology, VM network. So VM network essentially is the same thing as a virtual network. Okay, I want to just make sure that there's no confusion there. When we talk about virtual network, that's a VM network in SCVMM. And also, if you use a PowerShell, that's a routing domain. So we use the routing domain. But essentially, the three things are the same. So we want to make sure that way, keep clear that concept. VM network. So what is a VM network? So VM network essentially is the tenant boundary. It's a tenant network's boundary. So when we say bring your own IP address, bring your own topology, and that actually happens in that container, in that boundary, within that boundary. Now, how do you route between a virtual network to another, between a VM network to another? You have to go through an HMV gateway, and which is in the next slide I will talk about. You have to go through that. A virtual network will actually include multiple virtual subnets, and we call it VSID. VSID, I think the best way to understand VSID is just to think about it's a VLAN. Because essentially, a VSID is just a broadcast domain. It's a broadcast boundary, a layer 2 MAC address broadcast boundary. Okay, so that's VM network, which is equivalent to virtual network. If you hear me use these two terms interchangeably in this session, just understand I talk about the same thing. And then VSID. The only difference is, we'll talk more about it, the only difference between VSID and the VLAN is in VSID we support 16 million VSID instead of 4,000 VLAN. So the picture actually gives you, probably says better. So you have a multi-tenant data center. You have the usual customer, Contoso, and the Fabricant. They have this VM network on each side. And within each of the virtual network, they have multiple VSID. Right? Contoso have a 3 VSID. They have a 3 MAC IP subnet, 3 MAC address broadcast domain. And the Fabricant has a 2 VSID. Right? Now, between Contoso and the Fabricant, they can actually have its overlapped IP address. Why? Because the VM network provides this isolation. Right? Okay. So that's VM network and VSID. So the next concept I want to talk about is gateway. Because you probably hear us talk about gateway a lot. And there are really 2 gateways we are talking about that we need to differentiate. The first one is a default gateway. So essentially, a default gateway is it's basically just an HMV filter in the Hyper-V switch. What it does is, I think the best way to understand it, the default gateway is just to think about our HMV as a router. Okay. Because if you see the previous slide, right, you have each virtual network can have a multiple VSID, right? Now to enable routing between the VSIDs, just like in the past, to enable routing between VLANs, you have to go through router. So we enable the HMV, allow you to do that. So essentially, the HMV is a router. So once you understand HMV is a router, then you probably understand for every router, there need to be a router interface, routing interface, right? For each routing interface, there must be an IP address, right? So that's why we reserve the DAR1 address. So you hear us, if you read some documentation, you look at our scripts, you will see we reserve this DAR1 address. The DAR1 address is reserved for the routing interface on this default gateway, which is essentially implemented in HMV. The second gateway is HMV gateway. Now, in the previous slide, I talked about you have this VM network, virtual network. To route between the two virtual network, the traffic must go through HMV gateway. Whether it's an inbox, we actually support we have a built-in inbox HMV gateway in R2, and we also have a third-party HMV gateway. The traffic routing between virtual network has to go through this HMV gateway. So HMV gateway is for virtual network. Now, once you see the HMV gateway is for virtual network and the other network, so it comes actually with 3 different forms, right? It depends on your scenario. So let's look at each of them. So on one side, just recap, on one side is HMV and the other side is something else. Now let's say the something else is the customer's remote office, remote network. So how do you reach from the HMV network to your remote side network? Well, you need a VPN, right? So you need to enable a side-to-side VPN function on this gateway so you can bridge this HMV network and the remote side network. Now, what if actually the other side is not the remote side, basically just internet? You have the HMV network on one side and the internet on the other for scenarios. For example, you have some web servers on the virtual network, right? And you want your users on the internet to reach your web servers. So you need a NAT. So you enable the NAT function on the gateway. And the third one is actually think about the private cloud. In the private cloud, you want to use HMV. You want to create these virtual networks. Now, you have some other resources on your physical network, right? So from the gateway's point of view, one side is HMV network, and the other side is your physical, traditional VLAN-based physical network. How do you enable routing between them? Basically, you enable the forwarding function. So essentially, there are 3 functions on our inbox, on HMV, that's speaking for our inbox gateway. There are 3 functions on our inbox gateway. For remote side, you use a side-to-side VPN. For internet, you use a NAT. And if you want to route to your physical network, you use forwarding. Okay. So now let's talk about packet format. Let's talk about NVGIE. You probably heard of it. So to talk about, let's again look at the example. So we have 2 customers, Contoso and Fabricant. So we have they are using exactly the same IP address, which is totally legal. They can just because they own their IP address. And it happens to be that the 2 VMs, the 2 tenants VMs are hosted on the 2 physical Hyper-V hosts in the data center. Now, without HMV, this routing is impossible, right? Because if they have exactly the same IP address, how do you route such traffic? How do you differentiate the packet on the wire? So that's why we use the overlay method. We use the packet encapsulation, and we call it NVGIE. So what NVGIE does is encapsulates the tenant, the customer's address. It's the inner packet. So, and then put the provider's host's address on top of it in the outside pattern. Right? And the way to differentiate the 2 packets is using the VSID. And the VSID is in the GRE header. Now, NVGIE is based on GRE, if you are familiar with networking. It's a standard technology. NVGIE is also standard. We actually submit drafts to IETF, and you can download copies from their website. So that's actually how it differentiates these 2 packets, right? From left, same IP address, same provider address, and we use actually but we put them on 2 different VSID, and that's how we differentiate these. Okay, this is customer address, this is provider address, and this is VSID. Okay, so we talked about a few concepts. We talk about virtual network, we talk about VSID, we talk about gateway, we talk about packet format. Let's see how it works. So again, let's use the same example. From customer point of view, they onboard their topology, their VM to this virtual network. What they see is the address. They use their own address. They can choose their own address. From provider's point of view, they use the same method. They use the same routing protocol, address, assignment policy, just as before. Right? They don't have to worry about, they don't have to accommodate the customers. Thanks to the abstraction layer we use NVGIE to create. So in this case, you have two Hyper-V hosts, right? And actually, you can see the IP address, they may appear to be on different subnets. So as long as there's a connectivity between these two Hyper-V hosts, there will be connectivity between the VM tenants VMs on the two sides. So now, tenant will send a packet, right? What happens is NVGIE will encapsulate the packet. HMV will encapsulate the packet with the provider's address. And what we do is we use the SCVMN to plumb down, to configure the HMV to set up the address, lookup, routing information in HMV, so we actually be able to route the packets. Actually, I have more information. I have a more detailed slides on that. The basic idea is tenant send the traffic as if they are, sent from on their own physical network, but HMV will do the packet encapsulation before it send the packet to the provider's physical network. And as long as there's a connectivity in the physical network, you can continue to use a VLAN. You can continue, if you prefer to use a flat network, you as a provider, you can use that. So now I want to talk about what's new. So with all the concepts and with the overview, let's see what's new in 2012 R2. So first, let's take a look at what's actually in 2012. So in 2012, HMV essentially is just a lightweight filter, endless lightweight filter. If you are not familiar with the terminology, that's fine. Just think about HMV as a component inside as part of the Hyper-V switch. Just think about this as a component that is outside Hyper-V switch. Sorry, it's not part of the Hyper-V switch. In 2012, we don't have a lot of a control. We don't support a control protocol. Right? Our NVGIE doesn't actually have a control protocol because we are concerned about the scale. Once you have a control protocol, you have to make sure the control protocol is scalable enough so you can support a large network. We don't have a control protocol. Instead, we have this centralized management model. We centralize all the policies on SCVMN. It's up to SCVMN to push this policy to the Hyper-V so the routing can happen on each Hyper-V host. Remember, I talked about this default gateway. Right? The default gateway is a part of the HMV. So each default gateway can route or bridge the traffic. So what's new? I think I talked about what's in 2012. So what's new in R2? So in R2, we actually make HMV, this filter, we actually move it into the Hyper-V switch. So now this is actually a component, part of the Hyper-V module. And with that, we'll enable some new scenarios, and we'll examine each of these new scenarios. And we enable learning, dynamic learning. Because in 2012, as I mentioned, there's no control protocol. Everything has to be centralized. The policy is pushed by SCVMN. So there's no learning. There's no MAC address learning. There's no IP address learning. But with R2, we enable this capability to support the new scenarios. And Hyper-V clustering is another example. We'll look at it. And last but not least, right, we heard from customers HMV is complex. Once you deploy this, you have this virtual network, you have this physical network. How do you troubleshoot problem? When problem happens, how do you troubleshoot the problems? We actually have new tools to help you troubleshoot, diagnose problems. And we also talk about performance a little bit. Okay, so now let's do the real deep dive. So the first thing is architecture change. So remember I mentioned in 2012, this is the picture of 2012. You can see this is the HMV, and this is the Hyper-V switch. It's literally outside the Hyper-V switch. Now, because of this architecture, the problem is if we have a third-party extension, for example, NEC OpenFlow, Cisco 1000V, because they are as part of the Hyper-V switch, they don't get to see the physical address here, right? Because when the VM sends a packet, outbound packet, right, the third-party switch extension will see it, but the encapsulation happens here. And for the inbound traffic, HMV will do the decapsulation, remove the header before it sends to the Hyper-V switch. So if you have a switch extension here, it doesn't get to see the provider address. So that's a limitation. With R2, we move this HMV as a part of this Hyper-V switch. Right? So this really, with that change, we really make it possible for the extension, third-party extension here, to see both the customer address and the provider address. And with this change, we hope to enable the third-party vendors, switch extension vendors, to innovate and provide more support for HMV, for example, monitoring. Now you can write a monitoring tool to monitor both the client's address, based on client's address, or based on the provider's address. So we make that possible. Okay. So now let's take a look at the traffic flow. How we actually, with this change, how we make the scenario possible. So in this example, for the first part, let's see a packet actually is coming from outside. So the packet coming from, oh, it's too fast. Okay, the packet coming from outside. So you will go through the switch extension first, right? Because remember, when the packet from the physical network, it has this provider address. And because we send the packet to the switch extension, let's give the switch extension, the third-party switch extension, ability to look at the provider's address. And then HMV will process it. The HMV will, for example, remove the header. And then forward the packet to the VM. And when we forward the VM back to the VM, again, the packet will go through the switch extension. So in this time, the switch extension will see the customer address because of the HMV has already removed the outer tag, the outer head. Now, so this is the opposite. This is just exactly the opposite. For let's say the VM actually send the packet. Really the same idea. The packet from the VM will go through the switch extension first. Right? The switch extension will see the CA address. And then HMV will encapsulate it. And then we'll go through the MVGIE packet will go through the switch extension again, so the third-party switch extension can see it. So that's actually how we enable the coexistence of HMV and any other third-party switch extension. Okay, now remember I mentioned, like in Server 2012, we don't support this control protocol, right? Basically, everything is centralized. You have to statically configure it. We strongly recommend using VMM to configure this. But in doing so, we learned from customers, we actually are not able, with 2012, we are not able to support some scenarios. And the two most noticeable one is bring your own DHCP, and the other is Hyper-V clustering. And both of them actually rely on broadcast traffic to find, for example, in the DHCP case, to find, its own, for a VM to find its IP address. In the guest clustering case, in the event of a failure, you need to find out, you need to send out some packet with what we call DAT, duplicate address detection, and these control protocol all depend on multicast broadcast traffic. So we don't support that. We couldn't support it with 2012. So we make it possible in 2012 R2. But we didn't just go ahead and implement this, because our concern still remains. Once we enable this learning, the concern is, what about scalability? Right. Now, if you are familiar with it, if you know networking, if you enable broadcast, if you enable multicast, if things doesn't go right, it will severely impact your networking performance, and sometimes can just bring down your network. So when we think about this broadcast and multitask support, we didn't just go ahead and implement. We actually put a lot of thoughts. We actually implement a lot of smarts, and you'll see. So the first is, if the hardware supports it, if the NIC, the switch, your physical switch support broadcast and multicast, you can enable it. And what we do is we let the hardware to take care of broadcast and multicast. You can enable this configuration by using PowerShell or using VMM. However, we learned from many data center admin, we heard from many customers, they don't like broadcast. They just don't like broadcast traffic on the physical fabric. So if you cannot enable broadcast and multicast in hardware, what we do is we fall back. We fall back to something called a unicast replication. So what we do is we do it intelligently. Okay, so let's use an example. Let's say you have a customer is Contoso, right? A Contoso's VM wants to send a broadcast traffic. What we will do is we'll only send this ARP packet to the Hyper-V host where this Contoso VM is hosted. Right? We will send do a unicast packet. We'll send replicate this unicast packet, sent to the Hyper-V host. This Contoso VM is hosted. If the Contoso actually have multiple VMs on that host, we only send once, and that let the HMV on that host to further replicate the packets. Right. So the goal is simple. I mean, the goal is really to reduce the traffic as much as possible on the physical fabric. That's just the goal. We try to reduce the traffic. We try to reduce broadcast and multicast traffic. And I mentioned that we support all the common layer 2 broadcast and multicast semantics like ARP, DAT. Okay, one more thing. Actually, this is also important. Once we enable dynamic learning, we don't want to, every time a VM wants to find something, has to send out this ARP. HMV actually will be able to learn. We'll learn this address and either automatically configure this policy, or VMM will learn it and send down the configuration. And I actually have an example for that too. So let's take a look. Take a concrete example. Let's look at the dynamic learning. So in this case, we have a Contoso. So in the case of a Contoso, they still use the same configuration because they prefer static address configuration. Right. So in this case, you can see they use SCVMM to configure the policy. These are all static configuration. These are all the static configuration. Now a second tenant comes in. The second tenant is the Fabricant. The Fabricant wants to have this dynamic learning because the Fabricant wants to have this bring your own DHCP scenario. They want to have a virtual network, place DHCPs there, so other VMs on the virtual network can learn the IP address from this DHCP server. So what you do is, well, DHCP server has to have a static IP, right? Otherwise, who assigns the IP address to the to DHCP server? So for DHCP server, you use the static IP. Now, let's say you onboard, you bring another VM. That second VM, you want to learn the IP address from DHCP. So what happens is this web server, for this example, let's say this is a web server. The web server, when you onboard this VM, the web server will send the DHCP broadcast traffic, try to find the IP address. So when the packet comes in, HMV will do let's assume in this case, the multicast and the broadcast is disabled on the physical network. In this case, so when the packet comes in on the host, we'll do the unicast replication, and we'll only send the packet to host 1, because that's where the fabricant's server is. And the packet will come to the DHCP server, and we will return the packet back. Basically, the DHCP will assign the IP address. What you can see here is the packet is the unicast. Again, it's the unicast traffic. This return traffic is the unicast traffic. It goes back, and the server will get it. And what you can see is actually, let me go back. When the packet comes back, you can see the HMV here automatically plumb down a policy, right? It will remember which IP address is assigned to this server. It's assigned from the DHCP server to this web server. It will automatically configure it. So as admin, you don't have to configure anymore. You don't have to statically configure it. And also, see here, this address, we also configure the IP address, this lookup record here, this address lookup record here. And this address will be, SCVMN will plumb down this policy. So in future, let's say this DHCP server wants to talk to this web server, it has this address. It doesn't have to kind of find its way. It already has this address. So I think it's a time to do some demo to make sure really the idea, the concepts are really close. Okay. Oh, haven't switched yet. All right. So the first demo I'm going to do is bring your own DHCP server, just the previous slide. So in this case, I have a DHCP server here, right? And you can see it has a static MAC address, right? We assigned a static IP address to the DHCP server. And I'll have a DHCP client. This is a server. And if you run a IP config, and you see it doesn't have IP address assigned. Now, so come back to the Hyper-V host. The first thing I will do actually just to show, remember, this is the DHCP's IP address, right? So I just want you to pay attention to here. This is a static lookup record. Now, we just want to kind of walk slowly so you see exactly what happens. I want to run a command just to show that the server, the DHCP client, has this IP address, has this MAC address, right? 609, that's the last 3 digits. So if you look at the lookup record, there's no lookup record there, right? Because we didn't configure the static address. We didn't configure the static LA lookup record there. You don't have any. So now I config this dynamic lookup record. And what you can see here, what's different from a static configuration is you can see the custom address is 0000. And the type is layer 2 only. Basically, this is an indication that this address, the VM's address, is dynamic. It's going to dynamically learn rather than statically assigned. So now if we go to this server, if we do the config again, you can see it gets the IP address, right? Because we enable this lookup record, and this server constantly tries to find the IP address, and it gets one. It gets one from the DHCP server. Now, to actually make it more interesting, before I go there, I want to show, if you run the same command again, try to get this record. So now you see it. Now you have a this lookup record. And because of this lookup record, now you have a connectivity with other VMs. And you can see here this is a dynamic. This is a dynamic type. And to make it even more interesting, you can actually do static configuration as well. Let's say the server admin changed his mind. So instead of dynamic learning, he wants to enable static IP address. So let's do this. Let's say 200. Okay. So now this server has a static IP address. And the reason I want to show you is if we go back to here, if you run this command to enumerate all the lookup record, you will see there's an additional lookup record for this static IP address. Right. So if you're familiar with HMV, you know this is a lookup record. The lookup record has the MAC address information, IP address information, and the VC information. Based on this information, HMV can do switching and forwarding. So this lookup record is critical. Without it, you don't have connectivity. So this is the DHCP demo. Right? We showed how you actually can bring your own DHCP server and use it to assign IP address to your other servers. So next, I will show how actually gas clustering works. So move on to a second server. So in this case, we have a two-node cluster. So one node is on this machine, and the other is here. Okay, let me minimize this and bring up. This is the second node in the cluster. So the cluster has a VIP, a virtual IP address, and that VIP just happens to be 192.168.10.10. So I'm just going to ping it, right? So we keep pinging so the cluster is live. One of the node is live. So one of the node must have this IP address. Right? That's how the cluster works. So if we run here, okay, it doesn't return. Okay, so in this case, it doesn't have. So this node doesn't have this IP address. So that means the other node must have this IP address. I think I did the yeah. So this node has this IP address. So now what I'm going to do is I'm going to do a failover. This is node one. So I do a failover, right? So these are all live demo. I hope it works. Yeah, it does. So you'll see we missed one packet, but we actually resume the connectivity right away. So the node actually comes to here. Right, this is node one. Now, if we do, remember I did this command before, right? You see the red arrow. Now, if I do the same command again, so you can see now this node owns this IP address. This is the VIP, right? So this node owns this IP address. So this is the gas clustering support. Right? It's not possible in 2000 server R2. Also, it's not possible in 2012 because we don't support dynamic learning. But with R2, you can do that. You can do that. Okay, so that's the DHCP and the guest clustering demo. Let's move back to presentation. So the other enhancement we made in R2 is support of NIC teaming. Basically, let me put it this way. We make the support much better. Because if you remember in in 2012, when you have a NIC teaming, which is a very popular feature, when you have a NIC teaming and when you do configure NIC teaming and also use the HMV, what do you get from NIC teaming is you only get the HA, the higher availability part. You don't get the load balancing part. We don't support traffic spreading. Now with R2, right, we actually have, with this, if we've been to the networking overview session, we actually did the new dynamic mode. We support a new mode that we call dynamic mode in NIC teaming. It allows you to load balancing in both the inbound and outbound direction. And we also make sure that when you deploy HMV, the HMV traffic will be spread across the team members. We basically, the way to support it is basically we make sure when you configure the provider address, we allow you to configure MAC address because the MAC address will be taken into consideration when NIC teaming does the load balancing, does the hashing. To really leverage this load balancing, you need to configure multiple PAs. Right? You basically, the recommendation is for each tenant, each virtual network, each tenant has its own PA. Actually, no, each routing domain has its own PA, and then you can do the hashing. So we actually, for this one, we actually in TechEd New Orleans, we actually did a demo. So I'm going to skip this demo and do some other demos. So if you are interested in how this works, so I recommend you to go to the, take a look at that video and see how it works. So one thing, remember we talk about we use NVGRE to encapsulate the packet, right? So one question we commonly heard from customer is, what's the performance hit? So in terms of the in-cab and decab, we actually doesn't take a lot of a performance hit because it doesn't actually take a lot of CPU cycles. What you lose is actually the offload capability. And because of, remember, when you have this HMV, with the encapsulation, decapsulation happens in the software, right? The NIC doesn't see the MAC address, doesn't see the tenant's MAC address. And because of that, some existing offload technology just doesn't work. And one perfect example is VMQ. Now, if you think about VMQ, if you know VMQ, VMQ essentially allocates a queue in the NIC, and then dedicate that NIC to the traffic, the packet for that VM. And the way VMQ allocates the queue is based on the MAC address of the VM's MAC address. And the VM's MAC address is actually in the CA space. Right? And because we do the encapsulation, the NIC no longer see this customer NIC, the CA NIC. So as a result, you lose the offload capability. So what we do is, because once you lose this offload capability, you take a performance hit. Now, what we do is we work with partners. We work with NIC vendors, and to work with them to support what we call NVGRE encapsulation task offload, so that they can actually do the offload based on the information inside the packet. not based on the provider address. And we have actually in the SDN session, we actually have more information on this partnership with our vendors. So the last thing I really want to talk about is diagnostics. Right? So HMV is it's pretty new and introduced complexity. When you deploy it, now you have physical space, you have a customer space. When problem happens, how do you troubleshoot it? So we did a number of things. One is actually, how many of you actually heard of a message analyzer? Okay, so this is our next generation NetMount. So when we work with the MA team, the message analyzer team, we make sure they take into consideration of HMV so that when they pass the packet, they will pass the NVGIE header information correctly. And I'll have an example to show you. And the other two things is, now because of we have this PA address and the CA address, how we actually test the connectivity in these two layers. So we introduced what we call PA ping and the CA ping. So for the PA ping, I'll probably just do the demo and make the idea clear. So let's switch to the demo. Now, so in this case, I have two Hyper-V hosts, right? And HMV is enabled on it, right? And remember to enable to configure this PA address, we have to configure provider address, right? Now in 2012, once you configure the address, there's no way for you to find whether you can connect to that Hyper-V or not. The only way to find out is you actually deploy some VMs on top of the Hyper-V hosts, and then from the VM, and you see if there's a connectivity. Now with R2, we introduced this PA ping, so you actually, once you plumb down the provider address, you can ping the provider address directly. So on this Hyper-V host, I have this provider address 1235. So now move on to the first Hyper-V host. Right. So now I can ping directly. All you need to do is specify this P flag. So if I do ping, so I can ping. So this is good because if we want to test any two Hyper-V hosts in your fabrics in your physical network, whether there's a connectivity between these two Hyper-V hosts, you can use this command. You don't even have to deploy VLANs. You don't have to deploy VMs. You can just configure some provider address and try the ping. So the next thing is, this is a PA ping. This is a ping in the PA space, provider address space. What about CA? So now before that, let's say we have two VMs. We have two VMs on these two Hyper-V hosts. Now, ping is really a very common tool for almost everyone wants to, if anyone wants to test connectivity, they use a ping. So in this case, this is the two VMs belongs to the same tenant, right? And it pings the address because that's the address of the other VM. If you come to here, so this is the second VM this tenant has. Right? This is the IP address 10.10.14, and it pings it. Everything's fine. Everything's fine so far. But let's say, there's a misconfiguration happens. The tenant admin does something. Let's say to simulate this problem, let's say he configured the firewall. And then you notice I have this ICMP rule. And let's block any IP ICMP packet. Okay? So basically, we use this as a way to simulate some misconfiguration. Now, as a result of this configuration, if you come to this VM again, you can no longer ping. So what happens? So the tenant, usually the tenant admin will probably call you as a provider, hey, what happens? I used to be able to ping my VM, now I cannot ping it, what happens? So we introduced this CA ping, and this is a tool for the host, for the service provider to find out what's going on, to narrow down problem. So let's go back to the Hyper-V hosts, and enable. The CA ping has two parts. You enable on the receiver side, you enable the receiver, so the receiver can receive ping. And on the sender side, on this side, you do the send. So what it does is basically the Hyper-V will inject the ICMP echo, the ping. Right? So we basically do this, ping the CA address basically at the Hyper-V level. So with this ping, the ping succeed. So from Hyper-V, so from the service provider's point of view, there is connectivity between these Hyper-V hosts, right? So that kind of narrow down the problem. So the service provider's admin can tell the tenant admin, hey, there's really nothing wrong here on my side. Right? You better check your configuration, your VM configuration, and see if you have like some rules, like a firewall, some other rules that drop the ICMP packet. To really make sure it works, if we go back here, so the tenant, let's assume the tenant admin checks its configuration and find, oh, I mistakenly configured this firewall. Let me disable it. And now if we go back, once you go back, and you can ping again, right? This is just this tool, the PA ping and the CA ping, allows you to narrow down problem. And these are simple concepts, and we just hope it goes a long way to save you, if you're admin, save you some time when you troubleshoot the problems. Okay, so that's the demo. There's one more thing is, remember we talked about this default gateway, right? The default gateway is basically just an IP address on the HMV filter. Now in 2012, you cannot ping it. So that's kind of a limitation, kind of a bummer. And with R2, you are actually able to ping this IP address. So in this case, this is a very quick demo. So because we reserve this DAR1 address, so I know in this case it's always a DAR1 address. Interesting. Let me move on to this one. Oh, I think I entered the wrong IP address. I think it should be this one. Okay. So we'll figure out what's the reason this doesn't work. But the idea, basically, the idea is the DAR1 address is we reserved on the Hyper-V, in the Hyper-V HMV component. It will respond to your ping. So that's the demo. Oh, actually, I have one more thing. I'm sorry. One more thing is actually to show you the messenger analyzer. Which is here. So messenger analyzer allows you to remote log into a host, not remote, basically to monitor a remote machine, to monitor traffic and events on a remote machine using RPC, and get the information to your monitoring VM or your monitoring machine. And so you can do diagnostics. So I mentioned we worked with the team to make sure they are able to pass the NVGIE packet. So I did the capture earlier, and you can see we captured the packet. Right, this is ICMP packet, and it has the customer's address and it has the customer's MAC address, and then we have the NVGIE header. We have this NVGIE header information, and then we have the provider's address. Is 192 the provider's address space. So this is a message analyzer, and you can do the filter based on the provider address or based on the tenant address. So this really concludes our demo. So let's finish the presentation. And so the key takeaways. So the key takeaway is the Hyper-HMV essentially provides an abstraction layer on top of a physical network. And with that, a tenant can create a virtual network and then bring its own IP address, bring its own topology, no longer has to have a hard dependency on the physical network. And we implement this concept, this abstraction layer by using packet encapsulation. It's NVGRE. It's a industry standard. We work with vendors to support it, including test offload and other things. So in R2, we made a number of enhancements. And the goal is simple. We want to remove the hurdles, custom adoptions, hurdles as much as possible. We really hope with all the enhancement we made, that including the dynamic learning, support coexistence with switch extension, third-party switch extension, and also inbox gateway. We really hope these features will help you use it in your environment, or really use it in your production environment. So that's actually the takeaways I want you guys to have. So pretty much that's it. Just a quick reminder, please have any question, please come forward. Or actually, we have about 5 minutes. Any question I can answer here. Go ahead. The DHCP slide? Tell me where to stop. Okay. Yep. Oh, I think that's a typo. So it should assign 10007. Yeah. So that's a typo. Yeah. We use this size multiple times. You are the first one actually found it. Thanks. Yeah. We'll correct that. Okay. Any other question? All right. If not, feel free to come if you want to talk about other things. Really appreciate your time. Hopefully that helps. Thanks.